Hello, hi. So I think it's just you, Partha. So maybe we can wait for 2 minutes and then see. Maybe 7, 8 we'll start. If somebody is joining, then let's wait.
Okay, ma'am.
Okay, so we will start today's session. So, good evening and welcome to today's tutorial on urban utilities planning, water supply, sanitation, and drainage. So, we will be looking at week 11 today. We will be solving the assignment, previous year assignment questions of week 11. So, these are the topics which we learned in week 11. So, we looked at different mainly we looked at sewage disposal and treatment, and we saw into the natural methods of sewage treatment and artificial methods. So artificial method, we went into the details, looking at what are the primary methods, secondary methods, advanced methods. So we have gone in, so it's a lot of theoretical biological processes, chemical processes which are involved. So we have seen all these in detail. So we will try solving some theory questions based on the content that we discussed in this week. So this you already know. So directly we will go on to our question. So question one, what is sewage sickness? Option A, septic sewage being applied to soil having a high infiltration rate affecting groundwater sources. B, water getting unfit to use due to continuous disposal of sewage in water bodies. C, health complications in sewage workers due to continuous exposure to unsafe conditions. And D, soil pores get clogged during sewage farming, leading to anaerobic conditions. Yes, Partha, what do you feel? Which is the correct answer?
Option C, ma'am.
Sewage sickness, health complications in sewage workers due to continuous exposure to unsafe conditions. Okay. Uh, no, I mean, okay, did you just, was that a wild guess based on sewage sickness?
Still, I didn't watch lecture videos, so I don't know what is the
Oh,
answer.
okay. Then this week's might be a bit off because all these process like what because it's all theory questions and all the processes have been explained very well in the lectures only. So if I mean I can explain, but if I sit and explain the whole thing, then it'll be the same as lecture, and professor has explained it in a much more easier way in which you can understand. So yeah, so let's as and when some questions come, whatever theory is related to that, I'll explain. So yeah, so there's this concept called sewage farming, so which we in the lecture we have seen. So where sewage or the effluent which is coming from domestic or industrial sewage after collecting, after certain treatment processes, or sometimes there's only a primary treatment, or sometimes there's no treatment at all. If the quality is not so bad, there's no treatment also, and it's directly used for farming. So this helps in, so if for irrigation mainly, so you can reduce on the pure water which you're using for irrigation purposes by reusing this effluent or sewage water. So that we have discussed. So sewage farming, there are different methods by which this can be done. It can be just a surface irrigation, or it can you can make certain shallow depth ponds in which you can put this water. Okay, one second. Hello, Aishwarya. Sorry, we just started, so we're just discussing in the first question. Yeah, so there's this concept called sewage farming, and there are different methods of doing this, which there can be an underground pipe which goes through the farmland, and water can be penetrated to the soil and then used for irrigation purposes, or it can even there can be flooding where water is passed through a shallow pond and the crops are grown inside it. So there are different methods. So while using this method, one of the problem is that sometimes if the water is not treated properly, or if there are many impurities in the sewage, then the soil pores. So imagine we have the soil and we are using this uh, water for irrigation. So the soil pores can get clogged, and because of this there would not be much penetration inside. Or the other way, in case you're using so you have the farmland here, you're using an underground pipe and you're pumping in bad water which has a lot of impurities. So this will lead to, so we learned about different types of soil. So you will have porous soil, so you need this porosity for water to penetrate. So imagine our waste particles which are there inside, or the impurities which are there in the uh, in the effluent that we're using for sewage farming, ha- clogs these pores. So once these pores are clogged, this leads to anaerobic condition. So whatever chemical reaction which is happening after that, or leave chemical reaction, whatever happens inside the soil after that becomes anaerobic, and this leads to uh, development of methane, sulfur dioxide, and everything. So you get a lot of foul smell also. So from the smell itself, we can understand. So this phenomenon which happens to soil because of sewage farming by using untreated water, or by basically which leads to the clogging of the pores, soil pores, it's called a sewage sickness. So this is not a condition that we prefer. We want to eliminate this. So usually we do certain tests to test for sewage sickness, and then ensure that periodically there are tests which are done to ensure that the pores are not clogged, or if they're clogged, you unclog them so that sewage sickness does not happen. So yeah, so definitely C is not the answer. So this is just given to confuse you. And water getting unfit to use due to continuous disposal of sewage in water bodies. Again, this is water contamination, or the water or water pollution. Like this is not sewage sickness. And septic sewage being applied to soil, having high infiltration rate, affecting underground water. So this is pollution of the underground water sources, and this is pollution of the surface water sources. So these both mainly talks about water contamination or water pollution. And this one again to confuse you. So option D is the answer, where soil pores get clogged during sewage farming, which leads to anaerobic conditions. So this is what we saw in the lecture. So we have sewage farming, where sewage is used for growing crops, and that's called sewage farming. So the idea is that land acts as a filter. So yes, so the natural, as I was explaining, the natural method is that all whatever impurities are there will be stuck on the surface of the soil, and only water or there's a filtration which happens within this soil layers itself. So the underground water source is impure. That is what is expected. But this clogging can lead to sewage sickness, and that is something which we need to avoid. So yeah, so mineral salts of sewage such as nitrates, sulfates, and phosphorus are the main fertilizing constituents. So this act as fertilizers also. And then comes a sewage sickness, where the soil pores continuously decrease and the soil gets clogged by deposition of these solids. And this leads to anaerobic condition, that is air cannot circulate. So it leads to anaerobic condition, which leads to the production of hydrogen sulfide gas. So it gives a foul smell also. So by being in that place itself, we can understand that there is it's contaminated water which is being used. So how do we prevent this? So this can be prevented by using, after primary treatment, we have to so we need to remove all the suspended solids also. So primary treatment we have seen, mainly we remove all the uh, so like you grit or other elements which are there. So you, by physical examination, you're removing it, but all the suspended solids also needs to be removed. Then, so which means you need to have a primary treatment and you need to remove the suspended solids also. So you need treatment. Untreated water should not be used for sewage farming. Another method is to intermittently plow the region. So which means whatever clogging is there, when you're plowing, you're upturning the soil, and that can be avoided. Or you can use crop rotation. Now how will crop rotation help? Because if you have certain components which are on uh, causing this uh, clogging. Now, when you're rotating the crop, again, two aspects happen over there. You're uprooting certain crops and then you're planting others. So there is some amount of plowing which happens because of that. And also the chemical composition. The just one chemical component is not depleted from the soil. So you can make use of other chemical components also. So crop rotation also helps in avoiding this sewage sickness. And the next one is by providing under drainage system. So why this is important is that this under drainage system will automatically take away all the impurities. So it's an under drainage system. So it will not clog the pores of the soil, or it will not form a layer on the top of the soil. So these are some methods which can be used to avoid sewage sickness. Any doubts in this question? Shall we proceed to the next question? Okay.
Yes.
So next question is, identify the type of natural method of sewage treatment. So we have, so as I discussed in the previous one, we have different methods of sewage. So this is mainly, oh, a natural method. Oh, this is not sewage treatment. Actually, this is sewage farming. Like this, all these are different sewage farming methods. So you have ridge and furrow, flooding, lagooning, and managed turf. So which is this one?
I
Ridge and
think
furrow.
Ridge and Furrow.
Okay.
Ridge and furrow. Okay, so which is ridge, which is furrow? Here. So you have a form like this. Which is the ridge and which is the furrow?
The depressed portion is the furrow.
The depressed portion, correct. Yeah. So the depressed portion is the furrow, and this is the ridge. So this one, yes. So this is ridge and furrow. So you're planting on the ridge. In flooding, what happens? Where will we plant?
Uh, we'll plant it at the bottom of the ridge.
Yeah, so you'll plant it in the furrow. So if you have
Yeah.
the plant over here, then that is flooding. So essentially the structure might look the same. So you have, so flooding, what you're doing is you create these embankments, and then you allow, so you have these embankments and you allow water to go flow through this, or sorry, sewage to flow through this, and then you put your crop inside that. So which is used for plants which require a lot of water. So yes, and how is lagooning? In lagooning, what do we do?
Lagooning is you try to channel the sludge into a pond kind of a
Very good.
setup, and then
Very good, very good. So you have a pond, which is usually the pond, it's impervious, which means the water does not go underneath. So if it's porous, then this water will go and then start filling the underground water, right? So we use in a place where it's an impervious layer or the underground is already saturated. So mainly we go for impervious layer and the water is collected. So it allows the sludge or the waste, the impurities which are there to settle down. So usually what happens in lagooning is that all the sludge settles down and reaches, it settle down in the periphery. So it comes and it gets accumulated in the periphery. And this water which is there in the lagoon, inside the lagoon, is not very impure. So here we cultivate our crops over here. So that's lagooning. Now what is managed turf? What is a turf? Okay, so if we have, we might have heard, right? You play games in a turf or a ground, which is a turf. So
with
it's
grass.
exactly. So you have, yeah, so that's a grass turf, like where you usually have matches and all. So for all these turfs or for these low plantation regions, we can use this effluent or sewage water in order to in order to irrigate the surface. So it can be a spring irrigation which is used over here, or you can have some other methods by which. So this effluent is brought through certain irrigation pipes and then used to manage the turf. So as rightly said, so any green surface, so that's a turf. So to manage that, we're using sewage farming in order to manage it. So that's a managed turf. So we this is what we saw in the lecture over here. So we have surface, yeah. So something which we didn't discuss. So we have surface irrigation also, where you have just these parallel pipes which goes through the surface, and then the normal irrigation which is usually done. Then you have subsoil irrigation where the pipe goes underground, and then you're flooding. So this is what was there in the option. So this is flooding. And ridge and furrow, this is the answer to the question which we had. So we have the ridges and the crops are built on the ridges in ridge and furrow, and in flooding, the crops are in furrow. And then you have spray irrigation. So this is effluent being sprayed. So this is a type of managed turf. Your spray irrigation is a type of managed turf, we can see. And then we have lagooning, where the sludge is usually built up in the like you can see it's accumulated over here. Yeah, so yes, so coming back, yeah, so ridge and furrow is the answer to this. Any doubts in this question? Okay, so we'll proceed further. Question 3. The process involved in aerobic type of biological sewage treatment are A. Hydrolysis, bioreduction, biosynthesis. B. Glycolysis, hydrolysis, bioreduction. C. Hydrolysis, biooxidation, biosynthesis. And D. Glycolysis, hydrolysis, and biooxidation. So yeah, so many technical terms in this. So okay, any guesses for this question? This is a bit tricky question, so we'll see. Aishwarya, do you want to attempt this question?
no, ma'am, I'm not gone through this.
No, but you can say what I mean, you've seen the lecture, so you'll be able to attempt at least. Okay, Partha, do you want to guess something?
Might be option B.
Option B, glycolysis, hydrolysis, and bioreduction. Okay, Partha says option B. Anyway, something is better than nothing. You have a guess. Aishwarya, any guesses? Nothing. Okay.
I think it should be C.
You
Or
think it,
no, A.
okay. Hydrolysis, bioreduction, and biosynthesis. Okay. So the answer which Aishwarya gave is the popular wrong answer. In the sense, this is where you get
Okay.
confused usually. Like it can be because bioreduction and biosynthesis are there, we might think this is the answer. So this is a what you say a common mistake which usually happens?
Okay.
The answer is glycolysis, hydrolysis, and biooxidation. So we will see that D is the answer, but we'll see how. Again, we are mainly talking about aerobic type of uh, sewage treatment. So let's go. Let's first see what are each of these processes before we go into. So we have hydrolysis. In hydrolysis, the suspended organic material is converted into soluble organic material. So till then it was just suspended. So we have learned there are different types of impurities. There are suspended impurities, colloidal impurities, and this one uh, what completely it's completely soluble inside. So what happens is, so now you convert the suspended organic material into soluble organic material, that's hydrolysis. So basically you're breaking out something and then you're making them into soluble organic matter. So and then you have bioreduction, where the which reduces the number of microorganisms. So by bio, we know these are microorganisms, and reduction means the number of microorganisms which are there is reduced. So these are technical terms. It doesn't happen in this order one, two, three, or it's not given in the order in which it happens. The order can vary based on different processes that we are following. So here, first, we're just looking at the definition of these different processes. Then there's biosynthesis, which means the organic oxidized material is converted into microbiomass, which means by when the so there might be one bioorganism which is there, and when this organism reproduces, there are more microbiomass or more microorganisms which are there, so there's more microbiomass. So that's this biosynthesis. So more bioorganic in bacteria or whatever bioorganic microorganism is there, that is getting repeated or it's getting synthesized. Then you have glycolysis, which breaks glucose into 2 3 carbon components and generates energy. So this glycolysis we've learned in school, so we are aware of that. Then there's biooxidation, where the soluble organic material is oxidized into carbon dioxide, water, and this is ammonia. Yeah, so it gets oxidized into different components. So these are different terms. Now, in usual biological treatment, what happens is that, so why is it called a biological treatment? Again, because bioorganisms are involved and there's a biological process which is happening over there. So that's what we saw. There's a bioreduction and biosynthesis also, which happens. So what usually happens is we introduce these microorganisms into the sewage. Now these microorganisms, so first thing what happens is that the whole concept is that these microorganisms will eat certain components which are there, and then it will multiply. So during eating, something is happening. When it multiplies, something is happening, and then finally you reduce the number of microorganisms by using some chemical processes. So that's the whole process. So even before these organisms eat the component, they need to make it suitable for eating. So that's the first one. They secrete certain enzymes which dissolve the organic matter. And so this enzyme, so that is again what is happens in your hydrolysis. So this is the first one. So you have the first one where the enzyme, sorry, I went to the next question. Yeah, so where enzymes are produced, and these enzymes will dissolve the organic matter. So after it is dissolved, when it becomes soluble organic matter, then it can be consumed by these organisms. So this process is, again, we saw over here, this is hydrolysis. So hydrolysis definitely happens. So that is one. Then second, what happens? It eats. So the second one, so now simple terms, then it eats. And then the third one, it grows and it multiplies. So I'm just writing in very simple terms. So this is what happens. Now, what is the technical terms? We have already seen. So now let's see these. Yeah, so these organisms grow and multiply. Now multiplication can be in different ways. It can be binary fission, where each organism splits into two completely new organisms, or it can, like, so we've learned fission and fusion in our school. So here mainly what happens is binary fission. And this metabolism, so this process, so all this can be both aerobic and anaerobic. So aerobic, we know that oxygen is involved in the process, and in anaerobic, we know that oxygen is not involved. So it's anaerobic, there's no oxygen being involved. So let's look at the aerobic process. So in aerobic process, we see again hydrolysis, a first one, which is a suspended organic impurity. By virtue of hydrolysis, it's getting converted into soluble organic matter. So hydrolysis, pakka, it is there, hydrolysis. Done. Now what happens is, there are two simultaneous processes which are happening. So there is biosynthesis and there is bioreduction. Now we saw biosynthesis means it's multiplying, and biosynthesis means you're reducing the number of organisms. So these two are happening in two different directions. I actually now the direction or the path of our um sewage treatment process is ideally this one. This is the path of our sewage process. What happens in bioreduction is a byproduct. So you are having the component, some parts of it goes to biosynthesis, and then when some part of it, when the bioorganisms are reduced, then so bioreduction leads to all this carbon dioxide, methane, carbon dioxide, water, and ammonia is generated. Now, here the residual biomass, you need to have oxidation, or it's called auto oxidation. So using this oxidation, we are getting the other product, like again carbon dioxide. So this is the actual. So here it stops over here. Like in bioreduction, you're stopping it over there, which means it's you're not again further treating. Now over here there is a biosynthesis, and then whatever has been synthesized, that residual mass needs to be oxidized in order to form these components. So that's what is shown over here. Ammonia, which is formed by oxidation, we convert it to nitrate, and then we convert it to nitrite, and then we convert it to nitrate. So this is the aerobic process. In anaerobic process, what happens? In anaerobic process, here it stops, the bioreduction, and here it stops, and then there's bioreduction, and after that, it's there. So you have the residual biomass which is there inside. So which means you're ending with ammonia over here. Here, ammonia, again, it's again converted to other components also. So let's go back to the question. So in this question, we see option A, which shows that hydrolysis, bioreduction, and biosynthesis. Agreed. These processes are there. But if you ask whether these are the main processes which are there, maybe it's not, because where is oxidation? We are talking about aerobic type, which means auto-oxidation or oxidation is an important component which needs to be there. So that is why option A is not an answer. Had this oh, did I say that option D is the answer? Sorry, option C is the answer. You have biooxidation and biosynthesis. Yeah, option D is the glycolysis doesn't happen anywhere over here. So what happens here is, yeah, so glycolysis is not there. So option B and option D are ruled out, but oxidation should be there. If this option was not there, and if glycolysis was given in all the options, sorry, yeah, glycolysis was given in all the options, then we can say that, yeah, then this is the best option which we have. It will not be the absolute correct answer, but these three processes are there, so definitely it is. But since we have this option where you have hydrolysis, biooxidation, and biosynthesis, this is the actual step in which it moves. So we see we have hydrolysis, we have biosynthesis, and then we have oxidation, these three processes. Bioreduction is also there, but that's for the byproducts which are to generate energy. It's in a parallel path. So if the option had bioreduction also along with it, still it would be the correct answer. Just because bioreduction is not there, we are not eliminating that answer, because these are the three major process which is there. So as I said, this is a bit tricky question, and easily we can go wrong. We might think that A is the answer, but that's where we need to think that it's given aerobic, so which means oxidation has to be there. Okay, any doubts in this question? Okay, good. So we can proceed to the next question. Question 4. Which statement or statements are incorrect about biological treatment process? A. Biological sewage treatment involves aerobic and anaerobic microorganisms to decompose the organic and inorganic particles of sewage. B. Biological sewage treatment involves activated sludge process, sequencing batch reactor, and membrane bioreactor. C. Nitrogenous compounds are released during anaerobic process mostly. D. Bioreduction of soluble organic matter results in the release of hydrogen sulfide, methane, water, ammonia, and energy. And E. Methane production is achieved by aerobic process. So let's go option by option. Option A. Sorry, question by the, oh yeah, option A, biological sewage treatment involves aerobic or anaerobic microorganisms to decompose the organic and inorganic particles of sewage. Is that right?
Yes, ma'am, that is right.
Okay. So it's used to decompose organic and inorganic particles of sewage. Aishwarya, what do you say? Right or wrong?
No, ma'am, no, ma'am. Inorganic is like through chemicals, inorganics are decomposed, ma'am. I mean, degraded or
Okay, very good.
so it
Yes.
is false.
Yeah, so this is false because why? So that's the catch over here. We read till here, we might be, yeah, it is true, it's correct. But it says organic and inorganic particles of sewage. So inorganic, we need other methods. Biological sewage treatment will not just be adequate for that, right? So this is false. Correct. Now, B, biological sewage treatment involves activated sludge process, sequencing batch reactor, and membrane bioreactor. Is that correct?
It's true.
True.
Yes, ma'am.
Yes. We have seen this in the lecture. So these are the different process: activated sludge sequencing batch reactor and membrane bioreactor. Correct. Now C, nitrogenous compounds are released during anaerobic process mostly.
Yes, yes, ma'am.
Nitrogenous compounds are released during anaerobic process mostly. So let's just go back and see here. We have,
Ammonia.
yeah, so ammonia is a nitrogenous compound, but there's only ammonia here in anaerobic process. In aerobic process, you have ammonia, which gets converted nitrate, which is nitrite. So you have different nitrogen compounds which are there. The other, in this one, you have ammonia in the end over here, but you also have methane and hydrogen sulfide and water. So you have other, so these are also there, right? You have methane. Here, if you look, it's just carbon dioxide and water, and then ammonia or nitrogen compound. Here, but along with the nitrogen compound, you've got methane, you've got water. Again, we can just neglect water and carbon dioxide. We can, it's fine, but you have hydrogen sulfide and methane also along with it. So is this statement correct? Nitrogenous compounds are are released during anaerobic, which means mostly is also there, which means it's mainly nitrogenous compounds. Is it mainly nitrogenous compounds? No. So this is a wrong answer. Nitrogenous, it's not mainly. You have other. Had this been aerobic, then okay, it makes sense. But this is anaerobic. So for anaerobic, it is not. Now, option D, bioreduction of soluble organic matter results in the release of hydrogen sulfide, methane, water, ammonia, and energy. Correct? Not correct.
Correct.
Correct. We just discussed this right now. Yeah. Organic matter results in the release of hydrogen sulfide, methane, water, ammonia, and energy. Okay. Now, 3E, methane production is achieved by aerobic process.
No.
We just discussed. No, because methane can be produced by anaerobic process only. Just to remind you again, going back, this is the aerobic process. We don't have any methane formation over here. Is the, okay, I think the slide size is a bit small. So this is carbon dioxide, water, and ammonia, which is generated over here. Here, CH4 is there, which is methane. So in the anaerobic process, methane is uh, produced. Here, the question asks that methane is produced in the aerobic process, which means it's a wrong statement. So we have been asked to mark the incorrect statements. So we have got 3 incorrect statements, so which is A, C, and E. So A, C, and E, option D. Okay, any doubts in this question? Let's proceed to the next question. The oxygen saturation level is minimum in which of the following? A, clear water zone, degradation zone, active decomposition zone, and recovery zone. Firstly, what are these zones which are given? What do they denote? Oh, Aishwarya left. Okay. What are these zones that we are talking about over here? Okay, so these are,
Degradation zones, yeah, like it involves in biological treatment.
okay, very good, yeah. So there is there so these all these zones are for purification of, or these are the four zones which we mainly talk about for self purification. For self purification of the sewage, there are four zones which are there. So, or natural channels, we usually provide space for these natural or these zones are provided in the natural channel so that water undergoes self purification. So, yes, so initially you have the clear water zone, then you have degradation zone, active decomposition zone. So there are these zones. So let's, okay, any guesses for this one? Which is the answer? Okay, so let's see the theory. So this is what we saw in the lecture. So these are the four zones for undergoing self-purification. So you have the degradation zone, so which is directly next to the outfall where the sewage is through the pipes where it's going to undergo treatment. So it's just in the outfall. So what happens over there is that the water, it has maximum impurities at that time, right? There's no purification or there's no treatment. So we are assuming that there's been no treatment, and the water is going to undergo self purification only. So it's very dark, turbid, and there can be anaerobic decomposition of solid material also. Because why anaerobic? Because you're not oxidizing it, or you're not providing adequate amount of oxygen, or there is no organic compound, microorganisms are not added. So this is the initial phase. So that's a degradation zone. Then you have the active decomposition zone where there is full, that's where the whole decomposition happens. So if it's anaerobic decompose or anaerobic conditions which prevail, then we can get the odor of hydrogen sulfide. And because of all these impurities which are floating, there can be scum also, which is seen in this zone. Then comes our recovery zone where water is allowed. So you have a space where we allow water to stabilize. By stabilization, we mean that water is allowed to settle down. And then after settling down, we whatever, BOD stands for this biological oxygen demand, which is there. So over here, that oxygen demand is also reduced. And then, so here, okay, so this is in terms of oxygen, they're talking that there is more oxygen over here in this one. Now, whatever, so in active decomposition zone, you've got high level of bacteria, which we saw in the previous one we saw. So that the bacteria is eating and then reproducing in this active decomposition zone. So because of this, all the oxygen which is there will also be taken by the bacteria. And now, so this will be a biosynthesis. And now over here, we are reducing, it's a bioreduction also. Now what happens is bacteria, now the amount of bacteria which is there reduces because of decrease in food supply. So that what happens in the recovery zone. And finally, in the clear water zone, this stream acts as normal, so which means it's undergone self purification. So these are the four zones of self purification. So let's see. So all the physical conditions, the my organisms, living organisms which will be present in uh, these different zones are shown in this figure. Let's focus on the oxygen content because that's what the question asks for. So in the clear water zone, you have 100%. So it's like you have good dissolved oxygen. You have 100% dissolved oxygen. Then in the zone of degradation, so in the degradation zone, it slowly reduces. And then when it comes to the zone of active decomposition, it's the minimum. Why? Because this is where all the oxidation or the processes are happening. So if it's aerobic or an anaerobic, the amount of oxygen which is there in that zone, dissolved oxygen which is there in that zone is less. Because if it's aerobic, whatever oxygen is there, we are it's being used over there. And if it's anaerobic, obviously there is no oxygen. And then in the next one, so here we are again minded, we are talking about dissolved oxygen in the water or in the sewage. Then slowly it increases, and then there's a zone of clear water where it appears to be uh, again it reaches the saturation level, or the oxygen content is regained over there. Okay, so coming back to the question, which level has the minimum oxygen content, oxygen saturation level? So I think you can attempt this now. Which one is it? Hey, now active decomposition zone, right?
Yes, ma'am.
Yeah, which, okay, I think you got logged out a bit, right? So, fine. So, any doubts in this question? No,
No,
let's
ma'am.
proceed further. So, I think Partha got logged out. So, let's proceed. It's okay. So, now we have this question says 6 asks us to identify the different curves. So, okay, so we have, so this is a graph is given, and we've been asked to identify the elements in the graph. So let's go by A, B, C, D, like which, so the first one, any guesses on what it is? Okay, let's look at what are there in the options. So we have got equilibrium, DO concentration. DO stands for dissolved oxygen, so DO concentration, and oxygen sag curve. We saw in the previous one, there is sorry, yeah, so this is dissolved oxygen sag curve, which means the amount of dissolved oxygen is reducing, so which means there will be a sag. So coming back, yeah, so one is an oxygen sag curve, one is BOD curve, then or it can be reoxygenation curve. So we are seeing two terms, reoxygenation and deoxygenation. So reoxygenation means you're adding oxygen, and deoxygenation means you're removing oxygen. So that is D and re. So that's what's there. I think then what else is equilibrium, reoxygenation, deoxygenation, BOD curve. Yeah, that's it. BOD again, biological oxygen demand. So how is that changing? That is a BOD curve. So now let's see, what will A be? Any guesses? So what we,
Equilibrium.
very good, equilibrium. A is the equilibrium dissolved oxygen concentration. So what is there? So in a day time of the day, how is the dissolved oxygen content, or sorry, how is the dissolved oxygen content varying? That is what we are seeing over here. So yeah, so A is the equilibrium dissolved oxygen. So which means that if because it's the straight line, which means that's the equilibrium level, it is not changing at all. Then yes, what is B?
Oxygen sag curve.
Yes, very good. That is the oxygen sag curve. So during the course time of the day, the oxygen, so we saw in the art treatment process or cell purification also, initially it's saturated, then it goes down, and then when the process gets over or the active decomposition gets over, slowly it recovers. There's some amount of oxygen again being dissolved, and then finally it again reaches to its normal saturated point. So correct. This is the oxygen sag curve. Then what is C?
Reoxygenation curve.
Very good. C is reoxygenation. So, which means in this whole process, we need to keep giving an oxygen, or we need to keep adding oxygen. So, that is a reoxygenation curve. And if that is a reoxygenation curve, what will D be?
It is the BOD curve or deoxygenation.
Okay. Yeah. So this is the deoxygenation curve. So whatever is reducing, we are adding. Now BOD curve, BOD, it depends upon the the demand which is there, no? Like the biochemical oxygen demand, which BOD stands for that. So it depends upon the reaction. So in this curve, the BOD is not there. So you just have the reoxygenation, and then you have the de oh, sorry, this one, no, this is the BOD curve only. So that is already taken care over here. So you have this one, D is your BOD curve. So BOD value is reducing over here. So you have the reoxygenation. Deoxygenation amount is not oxygen depletion, which becomes a, wait, this is, one sec. We have, yeah, so it is the BOD curve only. It is the oxygen depletion which is there, but it is the BOD. So mainly BOD curve talks about whatever. So the demand is reducing, right, over there. So it is the BOD curve. So you were right. Sorry. So yes. So what does that work out to? Which option does will that work out to?
Option D.
Equilibrium, oxygen sag, reoxygenation. Yes, correct. Option D. Very good. Any doubts in this question?
No, ma'am.
Okay. Yeah, so this is the oxygen. So just to clarify that, because so this is the oxygen depletion, like the slope of this one, the slope of this one. So which is the so that is, so this is the BOD curve actually. So it, we might get confused with the deoxygenation, but we don't have such a thing in the graph. It's the so addition, which is the oxygenation, which is there, but this is actually the BOD curve which is given. Okay, let's go to question 7. Match the following and mark the option for the correct match. So we have surface irrigation, subsoil irrigation, flooding, and lagooning. So, which is given over here. So this in the beginning, first one itself we have discussed, so this should be easy. So let's see. Uh, Surface irrigation. Which one matches surface irrigation better? Is it sewage is filled in ponds between the dikes? Yes, no? Surface irrigation. Okay, take 2 minutes and you can attempt this question. Maybe let me not, because we just discussed this, right, in the first question.
S is 3. Lagooning.
Lagooning is 3. Sewage is filled in impermeable ponds.
Permeable
Very good.
pond.
Yeah, lagooning is 3 we discussed. Yes. So what is flooding? Let's go from bottom then.
Flooding is sewage is filled in ponds between the dikes.
Very good. Yes, this also we discussed. Sewage is filled in ponds between the dikes. Now, sorry, this one. Yeah, I marked it wrong. Yeah. Now, subsoil irrigation.
Sewage flows through porous pipes.
Very good. And then surface irrigation, sewage
4,
flows
ma'am.
onto the land surface. Yeah, very good. So that works out to which option? P is 2 and Q is 4. So option A, is it? Yeah, option A. Okay, option A. Any doubts in this question? No, okay. So let's proceed further. Question 8. Mark the correct statement for sewage treatment. A. Primary clarification involves a settlement of suspended solids. B. Secondary clarification involves removal of slimy organic substance through anaerobic process. C. Sludge digestion involves a digestion of organic and inorganic sludge from primary and secondary clarifiers. D. Grit removal process involves the removal of coarse inorganic particles. E. Screening process involves the removal of large size floating material through gratings. So let's go by the options. A. Primary clarification involves the settlement of suspended solids. Is that correct? Oh, wait, one sec. Previous question, did I say A is the answer? Sorry, B is the answer. Did I marked it wrong? It's 2, yeah. B is the answer. I'm sorry. Yeah, B is the answer. Okay. So, yeah, let's come back to this question. Primary clarification involves the settlement of suspended solids. Is that correct? Yes, no? It is, no. Like, what do we, so, by what do we mean? We have discussed this before also in one of our previous uh, discussions also we have discussed. So what does clarification do? So it, if you have some suspended or colloidal impurities which cannot be filtered out easily, so you add a clarifier and then you make the particles in a of suitable size such that it settles down, or you can easily remove it. Either it settles down, so you can take the pure water from the top. So primary clarification involves a settlement of suspended solids. So this is a correct statement. Now B, secondary clarifications involve removal of slimy organic substance through anaerobic processes. Is that correct? Okay, so this is partially right. Secondary clarification involves the removal of slimy organic substance. Very good. But it is not through anaerobic process, it is through the aerobic process. So this is wrong in that aspect. Had it been aerobic process, then it would have been the correct statement. Now option C. Sludge digestion involves the digestion of organic and inorganic sludge from primary and secondary clarifiers. Is that correct? We're talking about sludge digestion. Sludge digestion involves a digestion of organic and inorganic sludge from primary and secondary clarifiers. Okay, so this again is partially right. It involves the digestion of organic components but not inorganic sludge. So this is not right. So sludge digestion is only for organic. Now D, grit removal process involves the removal of coarse inorganic particles. Is that right? Yes, that is right. Because you have, yes. So grit again, grit is coarse inorganic particles, right? So grit removal is a process of you removing these coarse particles which can be easily filtered out, or by using a media you can remove the filter the grit out. So this is a correct statement. Now E, screening process involves the removal of large size floating material through gratings. Is that right?
True.
True. Yes, this is also true. What is skimming then? If screening you remove large size through gratings, what is skimming? Remember skimming? So this is another thing which we learned along with screening. So skimming is when you have these elements which are of very low mass, that the impurities which starts floating on the surface. So these from the surface you just skim and then remove that off. So this portion is skimmed outside. So here through gratings you're filtering it out, but this one you just skim it from the top. So that is skimming. Okay, so if that is the case, we've been asked to mark the correct answer. So we have got three correct answers: A, D, and E. So A, D, and E, option D. Any doubts in this question? So this is what
No,
we saw in the lecture also. Were you asking a doubt? Did I interrupt you, Aishwarya?
no, ma'am, no.
Okay, sorry, yeah. So yeah, so this is what we saw. So the process, so primary treatment can be screening, grit, suspended salts removed by settling. So this is what we saw. This was the first one. Plan involves the settlement of suspended solids. So yeah, so that is primary treatment. And then we have primary clarifiers are used for sedimentation of raw sewage. So sedimentation again, that is what we discussed in our option one. And yeah, oxygen is supplied for aerobic. This is okay. Secondary clarifiers are used for settling, sludge digestion. Yeah, so these are some details. So yeah, so digestion is settled out, including organic matter and microorganisms, both from primary and secondary setting. So we see only organic matter and microorganisms. Again, they are also organic matter, but not for inorganic matter. Right. So we have something flow equalization also over here. So this also, we'll have another question on that flow equalization. So let's go to the next question. During sewage treatment, grit is removed from sewage by the process of which of the following? Differential sedimentation, precipitation, stabilization, flocculation. Any guesses for this one? Okay, let's go by from the last one. What is flocculation?
Ma'am, it is differential sedimentation.
Okay, differential sedimentation. Very good. What is differential sedimentation? What is
Ma'am, I know about sedimentation, but differential, I'm not sure because of sedimentation, I said differential sedimentation.
okay? Yeah, grit can be removed. Yeah, so differential sedimentation involves you've got multiple chambers in order to do this. So you have a whole sedimentation. You have just
Okay, is it like arranged like
huh.
horizontally or something?
Correct, correct. Yeah, it is. So you have
Okay.
you have different layers. So from one you're sedimenting it out to another. So you have it's like you have differential equations. So I mean you can relate to that. Not it's not the how the name came or something, but the idea is you keep something and then you remove something. But there are certain things. So then the next stage you remove the other thing also. So you've got differential sedimentation. Now, I mean you can relate it that way. So precipitation, what is precipitation again? We have discussed this before. Okay, so if you have dissolved impurities, then we would like imagine there's salt in water. So you would evaporate the water out in order to get salt. So that is precipitate. Like it's a method by which you're using that. So similarly, there are other chemical methods by which you through precipitation you're getting it out. So that was evaporation. The example which I gave was evaporation. Similarly, you have got the reverse of that, which is precipitation. So you can get the pure pure water. It's a treatment process. Then you've got stabilization. So stabilization again, you allow it to stabilize and then you remove it out. Then you have flocculation. So this we have discussed before. You have got flocculation where you generate flocks by using some chemical components. You're converting the element into a flock, and then you're removing the flocks out. So this is what we discussed in the lecture. So you've got the grit removal. So what is grit again? So grit is any coarse element which has, and it will have different impurities of different specific gravities. So grit, the specific gravity of grit can vary. So this is very different from the normal water specific gravity, which means we can easily remove it. So these are the aerated chambers which you have. So this differential, because it's grit which has got different specific gravity as we discussed, so you can have different you can have sedimentation in order to remove it, and because these have different specific gravities, you can have multiple layers of sedimentation which is there. So that's what is shown over here. So you can have multiple sedimentation tanks. Now over this also, otherwise if it is in one tank, what do we do is that because it has got different specific gravity, you rather than the normal sedimentation, you allow the this one in a grit chamber, you allow the water or the effluent to go in circular patterns. So whatever because of the difference in specific gravity, it will be removed out from there, so the sediments can be removed out easily. So this is also vortex grit separator which also works in this. So this is one method for the differential sedimentation, and then you have these other methods also which can be used in order to remove grit. So yeah. Yeah, so it is separated from organic solids by differential sedimentation. Okay, any doubts in this question? No, okay, let's proceed further. Question 10. During sewage treatment, the coarse suspended solid particles that cannot be removed by screening, skimming, or grit removal process are removed by which of the following? Secondary clarification, chemical sedimentation, plain sedimentation, activated sludge process. Any guesses?
Activated.
Activated sludge process can be used, yes, but it's a more advanced method, right? So now again, we are mainly or advanced in the sense of, so let's look at the question. So we are talking about sewage treatment. During sewage treatment, now you're talking
Plain sedimentation, ma'am.
plain sedimentation, very good. Yeah, you're talking about coarse suspended solid particles. These are the initial ones, screening, skimming, or grit removal. Now if these don't work, the next one what we need to go with first, plain sedimentation. Now after plain sedimentation, then you go for secondary clarification, and then after clarification, then you can even go for chemical sedimentation and activated sludge process. Again, you can go in a much later stage, but the next one, immediate one, will be plain sedimentation, because these are the most simplest, very basic steps, and then you go for the next basic step, which is plain sediment. So this is what we saw. So yeah, clarifiers are used to separate the solids to prevent sludge banks. So you've got plain sedimentation and chemical sedimentation. So now if it cannot be removed using normal, so after screens and grit chambers, if we cannot remove it, then you go for plain sedimentation. So plain, that's the method which we usually, the process which we usually follow. Yeah, so the process takes place in a plain sedimentation tank, and is that is set after screen simmers in grit chamber. So we have seen the whole in the process diagram also, we have seen that after this one, the main screening, we have the plain sedimentation tank. Any doubts in this question? No, okay, let's proceed further. Question 11. The dosage of coagulant required for chemical sedimentation process depends upon which of the following? A. pH of the sewage. B. BOD of sewage. C. Nature of coagulant. D. Flocculation time. C. Size of the tank. So let's go option by option. First one, A. pH of sewage. Is it important to decide on how much chemical coagulant is required?
Yes, ma'am.
Yes.
Yes.
pH of sewage is very important.
Yes,
Then
ma'am.
B. BOD of sewage. Is that important?
No, ma'am. No, ma'am.
Why? Why is it not important?
It will be contained.
Sorry, I didn't hear you.
It will be done secondary. It will be done in second.
It will be done in second stage. Or you're saying that it is not done in chemical sedimentation. Is that what you're saying? Okay, okay, I understand where you're coming from. But it is important here because here we are talking about the dosage of coagulant, which means the dosage of chemical that we are putting in this step itself. Yes, in the next stage is where BOD content is being used or BOD is gaining importance, but then the dosage should be decided based on all the steps which are ahead of it, right? You can't stop after chemical sedimentation, then you need to remove like yeah, your so this one, the coagulant, you're adding the coagulant in order to create, increase the mass or to remove it out, right? So you need to consider the BOD of the sewage also while doing this. So yes, this is important. Now see nature of the coagulant. Is it
Yes,
important?
ma'am.
Yes, it's
Yes,
also important. Nature of the coagulant is also important. Deflocculation time.
yes, ma'am.
Yes, because it based on the flocculation time, we'll have to increase the dosage also, right? If it's going to take more time, then we'll have to change the dosage in order to have it in a lesser time because or you'll have to change the dosage. So then E size of tank. Is that important?
No, ma'am. Size of the tank is not needed.
No. Why? Because if you have a big tank or if you have a small tank, if the amount of sewage that you have is the same, then it doesn't matter on in what size that or the in what yeah what is the size of the tank. It's the volume or the quantity of sewage that you're putting or which is there that matters, right? So the dosage is based on all this other the chemical properties of the sewage and the volume which is there. So that's why the nature of the coagulant, the time, flocculation time, all these aspects, and it doesn't depend upon the size of the tank or the where it's located. It doesn't depend upon that. So yeah, so D is the answer over here. A, B, and C are correct. So which means option D is the answer. Any doubts in this question?
Yeah.
Okay, so let's proceed to the next question. Yeah, so this is what we saw, chemical sedimentation. So these are the different coagulants which are used, alum, ferric sulfides and all that. Now, dosage of coagulant depends upon the kind of coagulant, amount of impurities, strength of sewage, pH of sewage. So these we saw, these are additional strength of sewage, amount of suspended impurities, temperature of the sewage, then mixing flocculation time, which we saw, degree of treatment required. So these are the other aspects. Okay, so let's proceed further. Question 12. Self-purification of water bodies involve which of the following? A. Sedimentation, B. Aeration, C. Reduction, and D. Decomposition. Self-purification. Is sedimentation involved in self-purification?
Aeration.
Aeration is involved, yes. Okay, very good. Yes, aeration is involved.
Aeration, sedimentation,
Hmm.
decomposition.
Decomposition. Reduction is not there.
All the
All of them are there. So we saw
All,
previous
ma'am.
one. Reduction is
All of
also
them.
there everywhere. But the other one we said that reduction is not a main because oxidation was a main element and that was not there in the option where reduction was given. So that was a catch in the previous question. But all of them are involved. So let's see the theory. So this is the self-purification process. So you have first aeration and then you have sedimentation. And then after that, again, you have the absorption or decomposition. There's some amount of filtration also which is there. Then you again have sedimentation. So this is the whole process which goes. Now, reduction also happens in this process which is there. That is when you're in that decomposition, there's some amount of reduction also which is being present. So all of them are involved. All whatever in the self purification process, you have everything. Okay, so yeah, so that's what is given over here. You have dilution, then sedimentation, the temperature, yeah, oxidation, reduction. So all these factors play a critical role. Yes, so let's proceed to the next question, question 13. Match the following and mark the option for the correct match. So you have trickling filter, chemical sedimentation tank, and plain sedimentation tank. So which is trickling filter from this figure?
Option 3, ma'am.
Option 3. Yes, this we have discussed in one of the previous lectures also. This lecture also is there, but I think one of the previous lectures also trickling filter we have discussed. So you have this one, and then you have the water which is sprayed from the horizontal pipes. So it trickles down, so that's a trickling filter. Very good. Then you have chemical sedimentation tank, which is a chemical sedimentation tank. Just
Option 2.
option 2.
Hmm.
Yeah, so this we saw in the previous question, like we just saw this. This is a chemical sedimentation tank where multiple processes are happening, and then this is the plain sedimentation tank. So this also we have discussed in the one of the previous lectures where we discussed this is the inflow, and then from here, so you have these which will allow in removing out the sludge which is there, and then the sludge comes out through this. So you have the blades or the scraper which is there. So you and the the purified water is released outside through this. So that works out to P3, Q2 and R1. So option A. Right. Any doubts in this question?
No, ma'am.
Okay, let's proceed further. Yeah, so this is plain sedimentation. So sedimentation tank, yeah, so that's what, then chemical sedimentation. This one, so this slide we have already seen before, that's what. Let's go. Question 14. Which statement or statements are incorrect regarding sequencing batch reactor, SBR? So, A, it combines all sewage treatment steps into one unit. B, it involves 4 phases of treatment, that is fill, react, decant, and idle. C, during the react phase, BOD is removed through the oxidation process. D, it is effective for varying sewage flow patterns. So let's go option first one. It combines all sewage treatment steps into one unit. Is that a correct statement?
Yes, ma'am.
Yes, that's a correct statement. So the whole concept of sewage batch reactor is that it combines all sewage treatment steps into one unit. That's correct. B, it involves 4 phases of treatment: fill, react, decant, and idle. Is that correct?
Yes, ma'am.
Okay. 4 phases: fill, react, decant, and idle. It is correct. Fill, react, decant, and idle are there, but are they the only phases? Is it only 4 phases?
Actually, it is more than that, ma'am. But
Yeah, so that means that the
full
statement is
reality
wrong, right?
and
If it
I
is
is
more.
there.
So it has 5 phases actually. The statement is wrong. It has five
Uh,
phases. Fill, react, and then something comes over here. Any guesses what that is?
Settle.
Very good. Yeah. So you
I
need
think sediment settling.
yes, correct. Very good. So whatever is there, like you fill, react, and then after the reaction, you need to allow it to settle down. So there's settle, decant, and idle. And now see, during the react phase, BOD is removed through the oxidation process. Is that correct?
And
Okay, let's come back. Now, D, it is effective for varying sewage flow patterns. It is effective for varying sewage flow patterns, right?
yes,
Yes. So the only thing we have doubt is C, because we know that BOD is removed to some extent. Now, is it removed through oxidation process or not? That is the only doubt that we have. So let's look over here. So this is what we saw. So it has got 5 phases. One, so idle, fill, react, settle, and decant. So these are the 5 phases. So that's why option 2 was wrong. And now sequencing batch, yeah, that we already know that it will combine all the process into one. Now to look into in the react phase, mostly the BOD is removed or reduction occurs in the react phase, and mechanical mixing and aeration units operates on the wastewater at the rate of organic removal increases directly. So, yes, so here it said that during the react phase, BOD is removed through the oxidation process. So, nowhere is it mentioned that BOD is removed through the oxidation process. Because of that, this statement is wrong. BOD is removed, or there is reduction in BOD, that is true, but but it's not mentioned that it goes through the oxidation process. I understand that this is a bit tricky to know, but just I mean, one way of looking at it will be that in options, if you want to mark, if you want to say which is incorrect. So if you want to say only B is incorrect, there is no option which says that B is only incorrect. So C will also be there. So that's one way to go about it. But again, if B only option B was there, then it would be confusing, right? So in that case, I'm just explaining that in the react phase, BOD is removed, but this second portion, which says that it is removed through the oxidation process, is not the correct statement. So this is wrong. So answer B and C are wrong. Any doubts in this? No? Okay, let's proceed further. Question 15. Attached growth systems for biological treatment of sewage include which of the following? Aerated lagoons, moving bed biofilm reactor, stabilization ponds, and contact beds. So this is again directly from the theory only. So any guesses for this one? Okay, so for attached growth systems, the biological treatment involves contact beds. So let's go to the theory for that. So this is attached growth system. So what happens in an attached bed is that the treatment usually happens on the surface of the filtering media where we have a bacterial film is formed on the surface. So that's how the whole process happens. So then we have discussed the whole process. So there are some enzymes which are released, and then the inorganic components become, sorry, suspended components are dissolved. So all that happens, colloid and dissolved are absorbed. Then after that, they're absorbed within a few minutes in the trickling filter. So they are absorbed, and then the bacteria converts organic to stable inorganic. So all the same process which we discussed before happens over here. So now how it happens? So you need a synthetic media for it to happen. So this is the property of that synthetic media or the surface where it happens. So now for the sewage filter, which is used in the attached growth system, is you can have intermittent sand filters and you can have contact beds. So the filter media of the contact bed, so these are the specification of the filter media, how the contact bed is made. So here, none of the other options. Why it's contact bed? Because none of the other options which are given over here matches the attached growth system. So you do not have aerated lagoons in attached growth system. You don't have a, so again, you need a filter medium or a, but it's not a moving bed biofilm. Like this is a moving bed biofilm reactor, but it doesn't have a moving bed biofilm reactor in this. And you're not talking about stabilization ponds also. So it's contact beds which are there in attached growth system. Any doubts in this question?
No, ma'am.
Okay.
No, ma'am.
Okay, let's proceed further. Question 16. Yeah, so this again should be not very difficult. So let's see that aerobic process, anaerobic process, and facultative pond. So let's see what is P, an aerobic process, which will it be? Methane formation. So let's go with what we know. We've already discussed. So
Methane formation, ma'am.
methane formation happens in what? Aerobic or anaerobic?
Aerobic.
Methane formation happens in aerobic and anaerobic. We just discussed it today. Anaerobic. So methane and the hydrogen sulfide, everything happens in anaerobic when there's no oxygen. Whenever there's oxygen, it again gets decomposed and it continues, it goes into the water and carbon dioxide. So methane will not be formed in that case. So anaerobic is where methane is formed. We discussed this today. Then aerobic. So aerobic.
Shallow depth.
Yeah, so by looking at the options, this is an easy. So aerobic. So why, any logic why aerobic requires a shallow depth? Okay, so we have multiple oxidation processes which are happening. So for that to happen, you needed to have a shallow. If it's very deep, then that oxidation in the deep portion, it's very difficult for that oxidation to happen, right? So you need it to be on the surface or it's in a shallow depth so that these chemical reactions or oxidation processes can easily happen. So it's in a shallow depth, and the facultative pond will have both aerobic and anaerobic process. So we'll just see that. So yeah, so in the aerobic process, yes, so this is what we discussed. So it's in a shallow depth, and to maintain, so to continuously get that oxygen supply, you also stir it so that all the anaerobic conditions are prevented. So this is what I was discussing. In case you have a deep pond, then probably the oxidation, the aerobic reaction or the oxidation will happen over here, but over here it would be very difficult for oxidation to happen, right? Or like whatever you're supplying, in case you're supplying oxygen also, there might be, it is very difficult. So it's more prone to anaerobic conditions at certain regions. So that's why you keep stirring it, and at the same time you maintain a very shallow pond. Then you have anaerobic process. So anaerobic process, that's where methane is being formed. Yeah, so purification due to methane formation. Now, then you have the facultative pond, where both, so it has two stages where it acts aerobically at the surface. So that's what we are discussing. So on the surface, it's aerobic, and while anaerobic conditions prevail in the bottom. So these aerobic, they prevent all the odors. So we saw in the previous sewage sickness, in the first question we discussed. Whenever there's an anaerobic reaction which happens, it can lead to hydrogen sulfide also, which gives all these foul gases or methane formation, which can lead to foul smell. So it prevents. So this one, because of the aerobic conditions, it prevents the smell. At the same time, because of the anaerobic, you get the benefits of the anaerobic decomposition also. So this is best suited for treating sewage. Okay. So any doubts in this question? Let's proceed to the next question. Question 17. Dash integrate a semi-permeable membrane with a biological process. A. Membrane bioreactors. B. Trickling filter. C. Sequence batch reactor. And D. Secondary clarifier. Integrate a semi-permeable membrane with a biological process.
Is it trickling filter?
Trickling filter. So trickling filter we saw, right? What does a trickling filter do? You don't have a semi-permeable membrane in a trickling filter. So you have a filter, like water goes like this, and then you have a pipe like this, and then you put the water down like a spray. And then in this process, it gets filtered, and then the filtered water is removed out. So you don't have any. So what do you mean by semi-permeable? Only some amount of water is going through it, or it's semi-permeable. It's not completely permeable. So this one, integrate a semi-permeable membrane with a biological process. No, and again, where is a biological process happening in trickling filter? So it's not trickling filter. Sequencing batch reactor.
Then it's membrane bioreactors, right?
Yeah,
Membrane bioreactor.
very good. Membrane bioreactor is the correct answer for that. So that's the entire. Oh, okay, one sec. Yep, okay. So yeah, so membrane bioreactor is the answer for this one. Let's just discuss why others are not the answers. The sequencing batch reactor, that also we saw in the previous question. We discussed what are the processes which are involved in a sequencing batch reactor, and no way do we need a semi-permeable membrane. So this is not the answer. Then you have secondary clarifier, which again, why do you use a clarifier? Because in order to increase the size of the particles and then clarify it out or remove it out later. So this is also not secondary clarifier. Again, there's no semi-permeable membrane involved. So it is membrane bioreactor. So this is the definition for membrane bioreactor. So it integrates a semi-permeable membrane with a biological process. So it's a combined process like microfiltration with suspended bioreactor. So this, I think in the lecture, it's been explained very detailedly, so you can go to that. So you don't, no, there's no need for sedimentation, and biological process can operate as much in higher concentrations also. So you don't need to have, so it actually reduces all the processes which are there because of the biological process which is involved. So yeah, so this is the semi-permeable membrane that we are talking about. So it doesn't allow all the impurities to pass, so it's semi-permeable. So whatever passes through, you will get the clear water which comes out of it. Okay. So any doubts in this question? Okay, let's proceed to the next question. Question 18. Dash is a process in which particles deposited on the semi-permeable membrane of the membrane bioreactor surface tend to diffuse back to the reactor. So this is a continuation of the previous question. So on the semi-permeable membrane, whatever particles are deposited, it tends to come diffuse back to the reactor. And what is this process called? A, reverse osmosis, B, eutrophication, C, flow equalization, and D, intermittent permeation. Any guesses? Let's go option by option. Is it reverse osmosis? What is osmosis? We've learned this in school. I mean, if you've not seen the lectures also, we should be able to answer this. What is osmosis? When any liquid is allowed to pass through a semi-permeable membrane, it's called osmosis. So we have learned so eggshell is a semi-permeable not shell, the whiter coating which is there on the egg. If you remove the shell, it's a semi-permeable membrane. So you keep that, then you know that through that all the uh, particles or some of the whatever is inside can actually move out. Or simple terms, these are again. So let's go to reverse. So that is osmosis, what we have learned in school, where water passes through a semi-permeable membrane. Now, reverse osmosis is the reverse of that. So basically, in osmosis, if there's some salt concentration and if there's a semi-permeable membrane, water moves from a higher con higher dissolved concentration to a lower dissolved. So that's the whole process. So reverse osmosis, we might have heard about the term RO water filters and all that. So what it essentially does is, imagine we have something like this, and then you have a semi-permeable membrane over here. So now this is salt water, or you have high concentration over here, and through reverse osmosis, only the water which the so usually this is for salts, osmosis is for salts, but here we are talking about reverse osmosis, which means you have the water or the salts are retained over here and water goes into this and then you get pure water over here. So this is the basic principle of any RO filter, or it's used in any filtration process and all. So that is reverse osmosis. So in this particular case, it's not reverse osmosis because whatever particles which are deposited on the semi-permeable membrane tends to come back. So which means whatever is deposited over here should come back. So that's not what's happening over here. So it's not reverse osmosis. Then you have eutrophication. What is eutrophication? We've learned this in this lecture. So it's excessive growth of algae. So when you are using these microorganisms for purification, it can even lead to eutrophication where there's a excessive growth of algae. So that is termed as eutrophication. So that's not the case for this one. Then your flow equalization. So flow equalization also be in one of the previous questions I showed you. So there is something called flow equalization. So what it essentially does is, before designing the sewage treatment plant, we check whether the capacity of the treatment plant is adequate enough in order to cater to the treatment processes that are involved, or the volume. So you do a flow equalization. So whatever flow effluent is coming, is the volume of the treatment plant adequate? So presence of microorganisms. Did you say Pata types presence of micro? Was that typed before and I'm getting the message right now? Maybe so.
I also
Okay,
I
okay.
like sensory.
Okay, okay, fine. So that is flow equalization, where so it's in fact one of the primary steps of sewage treatment, where you plan the flow. So that's also not the answer for here over here. Then you have intermittent permeation. So this is the answer. So again, permeation. So we are talking about a semi-permeable membrane. So which means an intermittent means it's not continuous. So in small quantities, it's permeating. So it's intermittent permeation. So that's the answer over here. We'll see that in detail. So this is a biomembrane reactor. So you have intermittent permeation, where particles deposited on the membrane of the surface tend to diffuse back to the reactor. That is intermittent permeation. So that is what we are talking over here. Okay. Any doubts in this question? No doubts. Okay. So that's, I think that was the last question. Yeah, so that's it for week 11's discussion. If you have any doubts, you can ask now. No doubts? Yeah.
No doubt. Since I didn't watch lecture video,
Yeah, so I,
no doubts there.
yeah, these are all complete theory based. So it just directly comes from the lectures. So I think doubt also, there won't be much. So
Yes, ma'am. Actually,
are you speaking? I can't hear you. Okay, I can't hear you. Fine, anyway, because last two lectures usually you need to submit 10 assignments, right? So last two usually people don't attempt is what I've heard. So anyway, uh, so we'll have our last class mostly next week. And yes, so I had asked you, do you guys want an extra class on numericals alone for exam preparation?
Yes, ma'am. Definitely, ma'am.
Okay, great.
yes, ma'am, we need, ma'am.
If that is the case, then when would you prefer that? So because it will be an extra class. So 16th we'll have our normal class next week, and from 17th to 21st, anytime you can
Yes,
choose.
ma'am.
So uh,
Ma'am, can we have it on Friday? Not if that's not an issue.
you want to have it on 20th, is it?
Any day is fine for me, ma'am. From 16,
Yes, ma'am.
17, 18,
20th is fine, ma'am.
20th should be fine for everyone.
20th. Okay. So I was thinking 17th itself, so then you can get more time to prepare, but maybe you need some time to prepare and then come prepared for the class, right?
Yes, ma'am.
So, okay, 20th is good. So let me just check with NPTEL team whether I can get a slot on 20th. So, anyway, it will be between 17th and
Yes,
20th. I won't go to 21st because
yes,
when is the exam?
it's on 28th, ma'am.
So then 21st will be like you just have 1 week, right? So,
Yes.
okay, even maybe Thursday also we can see because why keep it till the last minute? You'll get more time to prepare later, right? So
Okay,
let
ma'am.
me just check with the NPTEL team. So between 17th and 20th, someday we'll have it. It will be announced. I'll announce it anyway before 16th. Maybe you'll get to know about it.
Okay, ma'am.
Okay,
Mm,
great
ma'am.
then. So thank you all for joining and yeah, good luck for your exam preparation. See you next week. So, yeah, bye bye.
Thank you, ma'am. Bye, ma'am.
Yeah,
Thank
yeah, thank you.